Hello and welcome to your Unit 12 review video on all things trig identities. So let's jump to it. At the top of the review sheet are the 3 Pythagorean identities that you have to have memorized. The first we call our old married couple, sine and cosine. They go back a long time. Together they make 1. The second is I tan for a sec. So read kind of backwards there. And the other one is I love cottage cheese. So these are kind of rearranged in a different order than you may have seen in your notes, but those are ultimately your identities that you have to have memorized with our funny little sentences to help you memorize them. Now, some other things to keep in mind are some identities that you would know from Unit 10. So zoom in here. Let's talk about tangent. We know that's sine over cosine. And we remember that because we go tanning in South Carolina. Cotangent is the reciprocal. Cosecant is the reciprocal of sine. And secant is the reciprocal of cos. And a way to remember that is cos backwards kind of looks like secant. So very similar. So before we jump into some of the problems, you can see we have some cute little jokes here. You can be cosine squared and I can be sine squared and together we'll be 1. We've got our identity theft. Look at him running away with all those Pythagorean identities. Don't forget we have our ASTC chart that's going to be relevant in what we do today, and also just a unit conversion for radians for when we need it. All right. So I'm just going to scroll through so you can see which ones I'm going to go through. So 1, 2, 4, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 19, 21, 22, and I think that's about it. All right. That should be a decent variety. All right, so let's jump right on into question 1 here. Using identity, solve for tangent of x given that secant of x is 2 on the interval of 3 pi over 2 to 2 pi. All right, now first of all, this is telling you a quadrant. If you guys envision where 3 pi over 2 is and 2 pi is, that's in quadrant 4. So when we look at our ASTC chart, and we're in the cosine quadrant, that means when I find tangent, my final answer will be negative. So we'll keep that in mind. Now, using identities, they're talking about tangent and secant. So my first thought is I tan for a sec. So that means my identity is 1 plus tangent squared of x equals secant squared of x, or theta if you wanted to have those be thetas. Now, when I give you secant of x is 2, that means I literally am just subbing that ratio in for all of secant and squaring it. All right, so now I just have to solve for tangent. Now, if I isolate tangent squared, this is 4 minus 1, which is a 3. Now, when you guys take the square root, you're technically getting 2 solutions, plus or minus radical 3. But remember how we said we're in quadrant 4, so tangent's going to be negative. So my final answer is negative radical 3. Okay, now number 2, we've moved on to a proof. This is not something you're going to cross multiply. I know that's very tempting anytime you have a proportion. You're working one side of the equation and making it look like the other. So if you want to draw the line down, you can. I'm not going to just for spacing with my pen that I'm using here, but I'm going to work one side. Now, I'm going to start on the left-hand side here because it just looks like there's more stuff to do. So first thing I'm going to do is actually write this out horizontally because I think this will be helpful for us. So this is tangent of theta divided by 2 sine of theta cos of theta, and I want it to look like this over here. Okay, oops. Now, a strategy that you can employ is writing things in terms of sines and cosines. So like for instance, I go tanning in South Carolina, so this is sine of theta over cos of theta. And it wants me to divide, so let's do multiplication, but do it by the reciprocal. Okay. Now, in this form, you guys can see that sine of theta will cancel out. As long as it's the same in the numerator and denominator with multiplication, I can make that cancelization. So now I have 1 over cosine of theta, actually 2 cosine squared of theta. Let me actually rewrite this, because it's 2 and then cosine times cosine. So 2 cosine squared of theta. Now, when you guys look at this, this is actually the same thing as 1/2 times 1 over cosine squared of theta. And you know what 1 over cosine squared of theta is? Secant squared of theta, because that's the reciprocal of cosine. When I actually do the multiplication, then multiply across the top and the bottom, I end up with secant squared theta over 2, which is exactly what I was looking to prove. All right, so again, some strategies that I've employed here. I took a division problem and I rewrote it horizontally. I rewrote things in terms of sines and cosines, and it wanted me to do multiplication. Well, technically division, so I changed it to a multiplication, carried that out. I looked for things to cancel, and then I even pulled a fraction apart here to help me see this identity a little bit more clearly, which allowed me to get secant into the problem to solve. Okay. All right. Moving on to number 4. Another proof. Okay. Again, start on the more complex side. Typically, that's something where like you have to do some like addition or whatever. So like I'm looking at this side right here. Now, my first thought is, again, let's deal with those sines and cosines. I know tangent is sine of x over cos of x. I know cotangent is then the reciprocal of that. Now, it wants me to add fractions. You know what I need to add fractions? A common denominator. All right, now in doing this, I've now created a sine squared of x plus cosine squared of x all over my common denominator of sine of x cos of x. You should be looking at this. You should be looking at this and saying, oh my God, they're so sweet, that old married couple. Together they make 1. So I have 1 over sine of x cos of x. 1 over sine of x is cosecant of x. 1 over cos of x is secant of x. And that's what we were looking to prove. All right, now number 6 is really ultimately a calculator problem for you guys. We are looking for the average rate of change, which means we're looking to do the slope formula. Make sure when you do these problems, you pay attention to the interval. So I'm just going to jot this down, little table here. My x is -3, and it's also going to be +3. So I need to find those corresponding y values. Additionally, they're giving you a frequency in terms of radians because you're in the real world. We're talking about a dampened sound wave, okay? So what I need to do is either change my calculator to radian mode or pay attention to pi over 2 being equivalent to 90 degrees, and then I can keep my calculator in degree mode. That's actually what I'm going to do, okay? So let me pull my calculator here. Let me just double check my mode. Okay, I'm in degree mode. Very good. Okay, so here's probably how I might tackle this, just because this is like a messy function, okay? First of all, let's actually store -3 as x. So you can hit that STO button, X, and what that means is anytime you hit X in your home screen, it's going to yield a -3. So that helps you evaluate. So that means I can type this expression as you see it and get it to evaluate. So I have 4 to the -0.3x times negative sine of, remember I said this was going to be 90x. All right, now double check that I type this in right because I have done this wrong before by accident because I'm working too fast. All right, that looks good. And I'm getting this negative 3.48 number. Oops. Now here's what's cool about the store feature. Now what I can do is store 3 as x because that's my next value I need to use. And now I can just go up and copy and paste that expression. And it's automatically going to evaluate it at 3. So it's like 0.28 number. Now, when we do slope, remember that's change in y over change in x. So we're going to go ahead and do 0.287 dot 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 minus this negative 0.348 number all over. Now in that same order, 3 minus negative 3. Okay, now I can do that in my home screen. Alpha y equals, okay, now I have that fraction bar. I can go up and grab that 0.28 number, go up and grab that negative 3 number. And then the bottom, I have 3 minus negative 3, which I know is going to be a positive 6. And then I hit enter. So to the nearest thousandth, I'm getting 0.628. All right, moving on to question 7. Consider the functions f of x and g of x. Determine which function has the largest maximum value in the domain of negative 2 to 2, and justify your answer. Let's actually start with g of x. So between negative 2 to 2, those are like x values, okay? I'm giving you a scale which implies that this is 1 and this is 2, which means this is negative 1 and this is negative 2. So between negative 2 and 2, what is the largest maximum? Okay. I'm seeing that maximum to be 2, 4, 6. So this one really just has a lot to do with paying attention to your scale. All right, so our maximum is 6. Okay, now let's come over here. What would the maximum be for this graph? Now, if I were to pay attention to a sketch of what this looks like, okay, you have a midline at 2, y equals 2. And regardless of the frequency here, you're starting on the midline, and you're going to end up going 2 below, which will put us at 0, or 2 above, which puts us at 4. Technically, this is a negative sign graph, so it's looking something like this. Okay? Now, at most, our maximum is going to be 4, because it's the midline plus our amplitude. So the question asks, which function has the largest maximum? Well, which number is bigger, 4 or 6? I think we all can agree that 6 is bigger. So to answer the question, the largest maximum is at g of x. And there's my work to justify it. All right, coming on down to number 8. I'm going to zoom in here. Solve for theta in the interval of 0 to 2 pi. When you guys see this, that means I want my final answer in radians. So we'll keep that in mind for the very end. For number 8, I'm going to isolate the cosine squared. And then I'll take the square root. Now keep in mind you're going to get plus or minus radical 3 over 2. And you're getting the plus or minus because you're taking the square root of something squared, so that yields 2 solutions. Now, if you guys go to your calculator and you do inverse cos of radical 3 over 2, what do you think you'd end up getting? Well, let's take a peek. If I do inverse cos radical 3 over 2, that yields 30. And you know what? That makes sense. If you remember our 1, 2, 3, 3, 2, 1 chart, cosine of 30 degrees is radical 3 over 2. All right, so I like to organize this using QRS. okay? That 30-degree angle that we just found, that's your reference angle. Now, technically the signs are both positive and negative, which means we're going to put that 30-degree angle in every single quadrant because of the positive and negative. All right, so here's your bow tie. Do some nice little contrasting colors here, okay? Now, as soon as you have your reference angle of 30 degrees in quadrant 1, that just is the reference angle, okay? But the rest of them you're going to have to do a little bit of math for. Okay, so this one's 30. In quadrant 2, it's going to be 180. Take away that 30, which ultimately gives you 150 degrees. 180 plus 30 would give you 210. And 360 minus 30 gives you 330. Now, those are each my answers in degrees. The thing is, though, I want radians. So, as a reminder, to convert to radians, you would multiply by pi over 180 and reduce. Now, 30 divided by 180 is the same thing as 1/6. So this reduces to pi over 6. Okay, now I can do the same thing for the rest of these. Like if I do 150 divided by 180 and math frac that, that's 5/6. So that means this is the same thing as 5 pi over 6. 210 divided by 180 is 7/6. So 7 pi over 6. And then lastly, 330 divided by 180 is 11 pi over 6. So final answers, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And those are in radians. So now I'm just going to move over to the right and look at question 9. Okay, so still solving here. Let's subtract over that cosine of theta. Now I'm going to utilize my factoring techniques. I notice a GCF. I can factor out that cosine of theta, and that leaves me with 2 sine of theta minus 1. All right, now let's tee it up. This first part is just saying cosine of theta equals 0. If we look at just a sketch of what cosine looks like, first remember, cosine kind of looks like a cup of water. I am hitting 0 right here and here. So think about your trig graphing. You know that the end of this is 2 pi, which means halfway in between is pi. But I'm halfway in between 0 and pi, which is pi over 2. Likewise, this is 3 pi over 2. So therefore, the angles I'm looking at for theta are pi over 2 and 3 pi over 2. That's this intersection for y of 0 and that. Now for the other guy, 2 sine of theta minus 1 equals 0. Let's do some solving. Sine of theta would equal 1/2. Okay? Now, QRS. Think, what is inverse sine of 1/2? Or even think about your chart. Well, sine of 30 degrees is going to give you 1/2. Now, this, if you look right here, this is a positive 1/2. That means that our quadrants must be 1 and 2. Because that's where sine's positive based on our ASTC chart. Alright, so if I were to draw a picture, my reference angle is going to be put in quadrants 1 and 2. And then if we're in quadrant 1, the angle just is the angle, 30 degrees. But in quadrant 2, it's going to be 150 degrees. Now remember the directions for this section, though, are in terms of radians. So that means my answers are actually pi over 6 and 5 pi over 6. By the same substitution and stuff that I did on the previous example. Okay? Oh yeah, and don't forget about these guys too. So we also have the pi over 2 and the 3 pi over 2 from the other half of this equation. All right. Number 10 I just hesitated on for a second. I thought about going through it, but ultimately, guys, when you do these types of questions, sketch a graph of every single one of these using your calculator if needed. Like this is your absolute value, which is under the math button. Here's a trig graph, which is oscillating between what? So 1 plus 3 would be 4 as a max, and 1 minus 3 would be negative 2 as a min. This is your log graph using math alpha math, and this is just a cubic function. So type them in, come up with a sketch of them. That's why this grid is optional, and then go to your questions. So that's my advice for that one. It's kind of hefty for the video, but when you look at the answer key, that's ultimately what you're going to be doing. Alright, so speaking of calculators and looking at graphs, I want to look at the graph of 3 sine of 0.125x minus 1 and this log function and find what the solution is, so where they intersect. Now, solution is implying an x value only. If I said solution to the system, then that would be an x and a y. Now, the trick with this question, which is really probably the hardest thing about this, is what mode is your calculator going to be in when you type this in? You're actually going to be in radian. And the reason is radian means real world. So if you want your x-axis to not be in terms of pi, because that's how we normally speak, like graphing this log function needs an x-axis that's not pi, then you need radian, because again, radian is real world. So we're going to use our radian mode, and we're going to use the option zoom 7. All right, so let me pull up my calculator. All right, so y equals, let's start typing in some stuff here. So I got 3 sine 0.125x, close parentheses, minus 1. Okay. And then my log graph is going to be my ln button, 5 minus 2x. Okay, now I got to change my mode because I didn't do that yet. Mode to radian. And now I'm going to hit the option zoom 7, which stands for Z trig. So it's going to know you're graphing a trig graph. So that first one was actually your sine graph. That's been shifted down 1 unit, and then there you have it. There's that ln function, or that log function going down. Now whenever you get answers from the graph, you should always sketch a graph of what this looks like, but I'm going to skip that just for the sake of the video. So sketch that picture. I'll do second trace, option 5. Oops, I hit the wrong buttons. Hold on a second here. Second trace, option 5. So it's jumping on my y1, so yes, you're on my y1, hit enter. Now it's on my y2, which is my log graph, so yes, hit enter again. And then for guess, there's only one intersection, so you don't really have to move it, but if you do, you just move it closer to the intersection you're trying to find. And then we hit enter one more time. And there you go, your x-intersect for thousandth would be 2.099. All right, moving on to another proof. I'll zoom in here so that's kind of more focused. All right, so the more complex side is very clearly the left-hand side. Now, something that's jumping off the page at me personally is this right there. That's I tan first sec. Okay, so if you want to, at step 1, you guys could really do tangent of x, cosecant of x, divided by secant squared of x. Okay, so notice how I just did that one substitution. Now I probably would start doing sines and cosines. So sine of x over cos of x. This is the reciprocal of sine. And then I'll still keep this as division for now because I don't want to get too ahead of myself. Divided by cosine squared. Okay, let's actually turn everything into multiplication. So that means this is going to flip. Okay, so look at what we got so far. I know these signs are going to cancel, which I'm sure you guys already started looking at right here. Now I can cancel one cosine in the bottom with one in the top. Look what I have left over then. Just a single cosine of x. And that's exactly what I was trying to prove. Done. So again, look at my strategies. I found this identity, I wrote the division out horizontally, I did sines and cosines, and then I did keep, change, flip. Okay, I looked for stuff that canceled, and then I'm good to go. Moving on to question 13. Okay, this one's actually a pretty straightforward one. Here's your old married couple. Together they make one. Here is I love cottage cheese. Guess what 1 over cosecant is? Sine. So this is sine squared of x. Done. That was an easy one. All right, what was my next question that I had picked? Question 14. All right, solve for all values of x in the interval of 0 to 360. All right, so let's isolate that cosecant of x. Now, I don't like it in this form. Actually, you know what? I was going to rationalize it, but now I'm hesitating, okay? So cosecant of x is 2 over radical 3. Let's think about that more as its reciprocal. Ah, that looks more familiar, right? So if I go back to QRS, and I want to find my reference angle, that means we're doing inverse sine of radical 3 over 2. So you guys can go to your calculator. Your mode is again going to be in radian because we want degrees coming out of this. So inverse sine of radical 3 over 2, which is 60 degrees. Now that should make sense if you have your chart memorized, but I'm showing you the calculator as a reminder. Okay? Now, again, this is a positive radical 3 over 2 when you guys look at this number. Like, that's why I'm getting positive. It's a positive value. So that means if you think about your ASTC chart, I know sine is positive in quadrants 1 and 2. So, looking between 0 and 360 degrees, I'm going to take that 60 degree angle and put them in quadrant 1 and quadrant 2. Now, if you're in quadrant 1, again, the angle just is the same as the reference angle. But if you're in quadrant 2, you're going to do 180, take away that 60, which ultimately gives us 120 degrees, because you're just 60 degrees shy of 180. And those are your final answers, 60 and 120. All right, moving on to question 15. What value of x in the interval of 0 to 180, ooh, interesting, satisfies the following equation? All right, so this one's a little bit more limited of a scope, so we're only going to look in quadrants 1 and 2, so I'll keep that in mind when I'm getting to my solving. Now, I'm going to isolate the tangent squared first. So tangent squared of x is going to equal 1/3, just by adding the 1 dividing by 3. We take the square root. Don't forget the plus or minus though, because anytime you take the square root of something squared, you're going to end up with 2 solutions, plus or minus. Now if I do a little bit of rationalizing, you're getting tangent of x equals plus or minus radical 3 over 3. QRS. Now, you're seeing signs that are both positive and negative. So normally I'd say you're in every quadrant, but remember how they said we're only going to look between 0 and 180? So you're just going to look in quadrants 1 and 2. And your reference angle is inverse tan of radical 3 over 3, which, if you remember from your chart, is 30 degrees. If it was radical 3, then it would be 60. So, but I just have my chart. You can go to your calculator if you don't remember that. Okay, so what we're going to do then, take that 30 degree angle, put it in quadrants 1 and 2. If you're in quadrant 1, your angle just is the reference angle. But if you're in quadrant 2, it's 180 minus 30, which is 150. And so your final answers are 30 and 50. So again, the only reason I'm not looking in quadrants 3 and 4 is because they restricted me in that domain. So I'm only looking in quadrants 1 and 2. All right, moving on to 16. Okay, and you just, first of all, solve for secant. Okay, and keep in mind we're going to look in all the quadrants, but our final answer will be in radians. All right, so let's clean this up a little bit. I have 4 secant of theta plus 8 by doing some distribution equals secant of theta plus 14. I'm going to subtract the secant and get 3 secant of theta equals 6. 14 minus 8 is 6. Now, if I divide by 3, I'm getting secant of theta equals 2. Now, I'm going to look at secant's reciprocal now, which is cosine. So if I know secant of theta is 2, cosine of theta has to be 1/2. All right, QRS. My reference angle is going to be inverse cos of 1/2, which I'm telling you is 60 degrees. Now, if you don't believe me, go to your calculator, inverse cos, 1/2, 60 degrees. Okay? Now, your value is positive because this is a positive 1/2. So now think about your chart, ASTC. Where is cosine going to be positive? 1 and 4. All right, so what we're going to do now is take that 60-degree angle and move him into those quadrants. Now, in quadrant 1, the angle just is the angle, so 60 degrees. But if we're in quadrant 4, that's 360, take away 60, which is 300 degrees. Now, the last trick to this problem, though, is remember how they wanted my final answer in radians, so we're going to have to do some converting here. So I'll take this and multiply by pi over 180, and that'll reduce to pi over 3. I can do the same exact thing here for 300. So you're doing 300 divided by 180, math fracking it, and that reduces to 5/3. So my other answer is 5 pi over 3. And that's 60 and 300 just in radians. All right, let's see. How many do I have left? Just a few. Okay. Question 18. Solve to the nearest degree in the interval of 0 to 360 this equation. Okay. So it looks kind of nasty, but here's what I'm going to do to make my life easier. Let's do a substitution. Let x equal cotangent of theta. So when I look at this, this is now x squared minus 3x minus 54 equals 0. Okay, let's factor that like how we normally would. Factors of 54 that sum to negative 54 that sum to negative 3. All right, I'm already thinking about 9 and 6. Okay, but I want this to be a negative 9 and I want this to be a positive 6 because I want them to sum to a negative 3. So if I solve, I'm very easily getting x equals 9 and x equals negative 6. But it wasn't really x, right? It was cotangent of theta. Now, I don't like thinking in terms of cotangent. Things are easier in terms of tangent. So let's change this to tangent of theta is 1/9. And cotangent of theta is negative 1/6. All right, let's do some work. Let's start with tangent of theta equals 1/2, or 1/9. QRS. All right, let's start with our reference angle. Inverse tangent of 1/9. Let's see what that is. So like 6.34, we'll say. Dot, dot, dot. Okay, I'm not going to round that. Now, my tangent is a positive value, which means if we think of our ASTC chart, tangent is positive in quadrants 1 and 3. So you're going to take that reference angle and have it in quadrant 1 and quadrant 3. Now, to the nearest degree, that means in quadrant 1, your answer is just 6 degrees. But if I take this reference angle and I take 180 and add it to put myself in quadrant 3, that's going to be about 186 degrees. Oops. Just vanished. So those are my first two solutions that I'm getting. Okay? So now we got to do the same thing for, oops, you know what I just realized? I'm sure you noticed this if you're watching this video. I wrote cotangent here. This is supposed to say tangent. Right? Because I flipped it. Okay. So now I have to come over here and do tangent of theta equals negative 1/6. Okay. Q, R, S. Now, when you do the reference angle, ignore the negative. The negative has everything to do with the quadrant, which I'll come back to. The reference angle has to be a positive answer, so I don't want to type in anything negative there. So if I do inverse tan of 1/6, that's giving me like 9.46. Again, don't round that yet. Okay? Now, think about your chart. A, S, T, C. I know tangent's positive in 1 and 3, so that means to be negative, it must be in quadrants 2 and 4. So to be in quadrant 2, we're going to do 180, take away that reference angle. To the nearest degree, that's working out to 171 degrees. To be in quadrant 3, or quadrant 4, excuse me, I have to do 360. Whoa. 360, take away that reference angle. And that's putting me at 351. And that's it. So my final answers to the nearest degree are 6, 186, 171, and 351, all rounded to the nearest degree in the interval of 0 to 360. All right, moving on to question 21. Using the Pythagorean identity, find tangent of theta to the nearest hundredth if sine of theta is negative 0.3 and theta is in quadrant 4. All right, here we go, guys. So all you have to do is take this ratio that they're giving you and sub it in for sine. Okay, now I know how a lot of you guys operate. Let's just plug it in our calculator. Negative 0.3 squared, make sure you're using parentheses, because that's a positive answer, 0.09. All right, so if we do 1 minus 0.09, we're getting 0.91. And then I take the square root. Now technically you're getting plus or minus the square root of 0.91, okay? Now keep in mind, if you're in quadrant 4 though, ASTC, cosine is going to be positive. So let's do this. Now, where do you guys go tanning? You should be thinking South Carolina. I know sine is negative 0.3 because they told me that, and cosine is the square root of 0.91. Let's go to my calculator. Oops, didn't mean to do that. Okay, alpha y equals, you can get a nice little fraction bar here, negative 0.3, and then the bottom, we're going to do the square root of 0.91. So to the nearest hundredth, I'm getting negative 0.31. And that, my friends, is using the identities to solve for tangent of theta. All right, one final question. Some trig graphing. I know, super exciting. I want to find where these two are equal ultimately. Where do they intersect? So, first of all, let's go through kind of our ABCs of graphing with this cosine graph. Our amplitude is 2, our frequency is pi over 4, which means the period is 2 pi divided by pi over 4, which using keep, change, flip gives us 8. Now, cosine looks like a cup, like that, right? So we're going to graph cosine on this graph. All right, let's do this. 2, 4, 6, 8. Who do we appreciate? And again, our amplitude's 2, so we're going to be oscillating between 2 and negative 2 because the midline is 0. And let's do it in the other direction too. 2, 4, 6, 8. Just dividing it into quarters is nice for us, just like 4 quadrants. So if I graph cosine, we're going to start above the midline and then at 8 end above the midline. Halfway, we're going to be below the midline, meaning we're going to hit our min, and then halfway, we're on the midline. There you are. That is one sketch of our cosine graph. Let's do another period of it. All right, and then I'll do a nice little label. So that's my f of x. Now, k of x is just a line. This is a y-intercept of -3 and a slope of 3 over 2. So up, 1, 2, 3 over 2. 1, 2, 3 over 2. I think you guys can kind of see where this is going from here, right? So if I were to connect these and draw a line, look at my cute little line tool, you'll see that they're intersecting right here at that x value. What is that x value? 2. That is the solution to this system, where we're finding the solutions to f of x and k of x, and I just want the x when it says solutions. So x's only, so x equals 2. Is f of x an even or odd function? So that's this blue graph. Definitely even. And you know why? It's symmetric with the y-axis. So it's all about symmetry. Oh my god, why did I say x-axis? I meant y-axis. Whoopsies. Symmetric with the y-axis. Now, fun fact, if we were talking about odd functions, sine is an example of an odd function because it would be symmetric with the origin, which means you can rotate it 180 degrees and it would look the same. Okay, so sine is an odd function, cosine is an even function. All right, guys, I think that was the last one I planned to go through with you guys. Yep, because the rest of them I've kind of already done in some capacity. So that's a pretty good variety of the different types of questions you could see in Unit 12. I hope this helped.